So at h is equal to a root 3 by 2, d2s dh2 is equal to, put the value, twice a square minus h square will be 3a square by 4, right? Into 3 root 3 by 2 ka cube. If you put h is equal to a root 3 by 2, this is what you are going to get, minus 8 ka cube into 3 root 3 divided by 8 minus, let's say this is plus or minus. This should be a minus sign here because, yes, then this should be a plus sign, and again we get a minus sign. Just a minute. So you put it here. This should be this is okay. Plus sign is okay. Plus, when you put h is equal to a root 3, then perhaps it will become negative. Anyway, let's put it. H is equal to a root 3 by 2, and you have 3k a square into 3a square by 4 minus 4k 3a square by 4 whole square. Okay. So this is what you are getting. Now this will cancel here, obviously. 8 and 8, and this 4 and this 4 will cancel. Divided by, and the denominator you also put h is equal to a root 3 by 2. Okay. So ultimately what you are going to get here is twice this a square by 4 you are going to get if you take the LCM, and here you are going to get 3 root 3 a cube by 2 minus 3 root 3 ka cube. So this you are going to get, see, you have a 3 root 3 a cube here, right? And how much do you have here? 3 root 3 ka cubes. Numerator is the same, only difference is the denominator. So if you take the LCM, you will get 4 root 3, 4 into 3 root 3 ka cube minus 3 root 3 ka cube, right? This is what you are going to get, right? So you are going to get here 12. Let's say yes, 12 root 3 ka cube minus 3 root 3 ka cube divided by 8. Okay, plus a root 3 divided by 2, and this will be 9ka to the power of 4 divided by 4 minus, this will also be 9ka to the power of 4 divided by only 9ka to the power of 4. Because 4, okay, 4 does not cancel here. My mistake. This should be, this is a 4 within a square, this is right. So only 1 4 cancels here, right? Let's not cancel this 4. Keep this 4 here so that you can get 9ka to the power of 4 divided by 4 only. This is what you're going to get, right? Whole divided by a square by 4 to the power of 3 by 2. Now see, this part becomes 0, right? So ultimately you get twice a square by 4. Now see, in the denominator, these two, if you see, they are the same. The bases are same. So you can subtract the powers. So 1 minus 3 by 2, right? And here 12 root 3 ka cube minus 3 root 3 ka cube by 8 will give you 9 root 3 ka cube by 8. Right? Okay. Let me just check once again. Okay, 8 and 8 are cancelling here, right? So therefore, this is also another mistake that I have made. 3 root 3 ka cube minus, this will be simply this will be 3 root 3 ka cube. If you take now, take the LCM will not be 8, the LCM will be 2, because this denominator is 1. This denominator here is 1, isn't it? Because you have cancelled 8. So 3, this will be 3 root 3 ka cube minus 2 ka cube, 6 root 3. Okay, 6 root 3 ka cube, right? So what you are going to get here is 3 root 3 minus 6 root 3 means minus 3 root 3. Okay, so now we have got the sign. What is the sign here? This is positive, and you have got a negative sign. 3 root 3 by 8 ka cube will be positive. So this is obviously less than 0, right? Thus, S has a point of local maxima at h is equal to a root 3 by 2. Right? Now, what is the question here? The question here is what must be the breadth of the stiffest beam that can be cut from the log of diameter A? So we have found a relation between the depth and the radius, right? They are asking to find out a relation between the breadth and the diameter. So which one will you use? We'll use relation 1. From 1, a square is equal to b square plus h square. Right? So that means a square is equal to b square plus h square is a root 3 by 2 square. So that means a square is equal to b square plus 3a square by 4. So that means a square minus 3a square by 4 is equal to b square. That means b square is equal to a square by 4. That means b is equal to a by 2. So that means breadth is equal to or is equal to half of the diameter, right? Isn't it? So that means we can say breadth must be equal to the radius. When stiffness S is maximum. Okay, any question?
Sir, how you did that calculation?
Which one?
Just that calculation part only.
Calculation part. Okay, tell me. This one.
Yes, sir.
Okay, now see here. If you see, I had cancelled this. I had cancelled this 8, right? If I
Yes, sir.
cancel this 8, what will I have left? 3 root 3 ka cube by 2, isn't it here? And what am I left
Yes,
here?
sir.
3 root 3 ka cube, right?
Yes, sir.
Here I'm left with 3 root 3 ka cube by 1, isn't it? Now, what is the
Yes,
denominator?
sir.
Denominator here is 2 and denominator here is 1. So now if I take the LCM here, the LCM will be 2,
Yes,
right?
sir.
Because the denominator is 2 and 1. Now if I take the LCM, now what should be a numerator? Here I have a 2, here I have a 2. So I wrote this numerator same, 3 root 3 ka
Yes,
cube.
sir.
And here I have 1. Here I have 2. So 2 divided by 1 will give me 2. And 2 into 3 root 3 ka cube will give me 6 root 3 ka cube,
Yes, sir.
right? Plus, and this part is obviously 0. I had cancelled this by mistake. Where is it gone? Yeah, here. Here I had this 4 and this 4 cannot cancel at this stage because I have a square here, right? Isn't it?
Hmm.
So that is why,
Hmm.
but I
Yes, sir.
cancelled it wrongly. So that is why I corrected it. This should be 4. So what happened? This part becomes 0 completely. We
Yes, sir.
only we only saw this part. So this part, what we saw was that a square by 4 is positive, isn't it? Even if it is the power is negative, doesn't matter. But a square by 4 is positive. And this once I take the LCM, 3 root 3 ka cube minus 6 root 3 ka cube will become minus 3 root 3 ka cube by 2. This should be not 8, by 2, right? Yes.
Yes, sir.
So that means this quantity here, 3 root 3 ka cube by 2 is positive. But I have a negative sign here. That means the entire expression has to be negative, right?
Yes, sir.
So that's how I calculate it. Is your query clarified or any other
Yes, sir.
question?
Okay, sir. Okay, sir.
This is, we'll move on to the next problem. Find the volume of the largest cone that can be inscribed in a sphere of radius r. So I have a sphere in which I inscribe a cone. Okay. If the sphere is given, then what is given to you? The radius of the sphere is given to you. That means radius of the sphere is constant, right? So I start by saying let the radius of the sphere be capital R. Here, since the sphere is given, R is a constant. So now what is the radius of the sphere? If we join these two, this becomes the radius of the sphere, right? So this length is your capital R. Okay. And now because we are inscribing a cone inside the sphere, what is the cone defined by? It is defined by its height and the base radius, right? So I start by saying let small h and small r be the height and base radius of the cone. So here R and H and R are variables, right? Are both variables. Okay, you need to find out the volume of this cone such that it is the maximum. Okay, so what you do here is let's label this. We have taken the base radius here to be small r, right? And we have taken the height of this cone to be small h, right? So now what can you say? In this triangle, you see this triangle, let us call the center of this as O, let us call this as P, and let us call this as L. Now if you see in this triangle OLP, what is the relation between a small r, capital R and H? If you see what is OP, what is the length OP? If you see this is R, then this is also R, right?
Yes,
So
sir.
therefore OP must be equal to capital H minus R. You agree?
Small h
Yes, sir.
minus r.
Yeah, small h minus R. You agree?
Yes.
Okay. Now in triangle OLP, you have hypotenuse square, that means capital R square is equal to perpendicular square, which is OP square, plus LP square. LP square is small r square. This is the relation between this is the relation between the variables small h and small r. We call this 1 because this relation will help us eliminate the two variables in eliminate one variable in the function that we need to maximize, right? What is the function that we need to maximize? We need to maximize the volume of the cone. Volume of the cone. What is the volume of the cone? 1/3 pi
Correct.
r square h, right? Now,
Correct.
if you see, you have two variables here, r and h. Let us call this v. Volume of the cone v. If you see, volume has two variables, r and h. I want to remove one variable. Let us remove r square here because I have r square here also. So it will be easier to remove r square. So let us remove r square. So from 1, small r square is equal to capital R square minus h minus r whole square. Okay, putting this value, let's call this 2. Putting this value into, we get v is equal to 1/3 pi h r square minus h minus r whole square, right? Now this, are we down to a single variable or not? Are we down to a single variable?
Yes, sir.
We are down to a single variable h, right?
Because capital R is constant.
Because capital R is constant. So therefore, now we differentiate. Therefore, dv dh. Now you can simplify this. You can expand and simplify this expression. But I think it will be easier for us to differentiate like this. Okay. You can simplify this and then differentiate. Otherwise, I think this should be easier to differentiate. 1/3 pi. Okay, this is your constant. You take it out. And h into r square minus h minus r square, you differentiate by u into v rule. Okay. So if you differentiate, first r square minus h minus r whole square, you write as it is. Into ddh of h, which is 1, right? Next you have plus. Now you keep h as it is and you differentiate r square minus h minus r whole square. So what will you get? ddx of r square is 0 minus ddx of ddh of h minus r whole square is twice. First you differentiate the power h minus r into ddx of h minus r, which is minus 1, right? Differentiation is okay.
Yes, sir.
So now what we do here is we expand this r square minus h square plus r square minus 2hr. This, and here your minus and minus combining to give you a plus sign, plus twice h minus r, twice h, I think, yes, twice h minus r. Okay, so now this will be 1/3 pi. Now you have r square minus h square minus r square plus 2hr. Okay, and you multiply with h throughout, minus 2h square minus 2hr, right? So there are certain things that will cancel here. For example, this r square will cancel, plus 2hr and minus 2hr are going to cancel. You are only left with the, oh, this should not cancel because this is not minus. This is a plus sign. 2hr is a plus sign here. And if you see, this also will also be a plus sign, isn't it? Because this is a plus sign. Oh, this should be a minus sign only. Zero minus. Is this a minus sign? Okay, this should not be a minus 1 here because we are differentiating with respect to h, right? This should be a plus 1 because if we differentiate h minus r with respect to h, you'll get a plus 1, isn't it? So this should be a minus here. Okay, so minus 2hr. Now this is plus 2hr. So that is why it will not cancel. 1/3 pi. And now what are you left with? You are left with
Minus
4hr
3h.
minus 3hr. Okay, this is what you are left with. So for maximum or minimum volume, dvdh is equal to 0. That means 1/3 pi 4hr minus 3h square is equal to 0. That means 4hr minus 3h square is equal to 0. That means from here, now you can take h common to get 4r minus 3h is equal to 0. That means 4r is equal to 3h. That means how much are you getting the value of h? H is equal to 4r by 3. Right? So at this value, the volume of the cone is either maximum or minimum. How do you check for maximum, whether maximum or minimum? Second derivative test, d2v dh2 ddh of dv dh. And what is dv dh? ddh of 1/3 pi 4hr minus 3h square. Now 1/3 pi is a constant, you can take it out. Into differentiation of 4hr with respect to h, you will only get 4r. Minus, and differentiation of 3h square is 6h. Right? At h is equal to 4r by 3. What is the sign here? d2v dh2 is equal to 1/3 pi 4r minus 6 into 4r by 3. So how much are you getting? 1/3 pi 4r. This will obviously cancel. Minus 8r. So is this positive or negative? 4r minus 8r is negative. 1/3 pi is positive. 4r minus 8r is negative. Thus, V has a point of local maxima at h is equal to 4r by 3. Right? Now, what is the question here? If you see the question here, find the volume of the largest cone. You need to find out volume. You've already found out the relation between height of the cone and the radius of the sphere, right? So, what should be the volume of the cone? You find out the relation between the radius of the cone and the radius of the sphere. So from 1, we use 1. So from 1, what was our relation 1? Relation 1 was or what you can do is you can because you have found out a relation between h and 4r by 3, you can also use this because you need to find out the maximum volume, right? You can put it here only, right? So maximum volume Vmax at what? H is equal to 4r by 3. Put the value here, 1/3 pi into 4r by 3, because 1/3 pi h we had 4r by 3 into r square minus 4r by 3 minus r square. This is from 2, right? You just put h is equal to 4r by 3 in 2. Now simplify this, you get 4 pi r by 9 into r square. Now you expand this, or you can simplify this and then expand. Minus 4r minus 3r will give you r by 3, right? That means you get 4 pi r by 9 into r square minus r square by 9. So you get 4 pi r by 9 into 8 r square by 9. So how much do you get? See, you have to show that it is, if you see, read the question, it says find the volume of the largest cone that can be inscribed in a sphere of radius r. Okay. So what you see here is this is the volume of the largest cone. So let's write this as 32 pi r cube divided by 81. You can leave your answer here. Or a better way is, because you see you are getting a pi r cube here, what is the volume of a sphere? It is 4/3 pi r cube. So if I can separate 4/3 pi r cube from here, which is the volume of the sphere, I'll get this as 8 by 27. So what do I see? I'm getting 8 by 27 times the volume of the sphere. Okay. So what is the maximum volume of the cone? Maximum volume of the cone is 8 by 27 times volume of the sphere. Okay. So you can leave your answer here also. Okay.
Yes, sir.
We move on to the next question. Now the
Uh,
next question. Yes.
Nothing, sir. But what?